In this session, we are going to solve the third problem in part A of the Java lab. The third problem reads as follows. This program reads two numbers having the same number of digits. For example, you have two numbers 327 and 539. If you look at here, there are same number of digits are there. So first digit, second digit and third digit. Three digits are there. First digit, second digit and third digit. So three digits are there. So both of them contain three digits. The numbers and the digit need not be same, but the count of digits, that is, this one also has three digits and this one also has three digits. So there the number of digits must be same, the digit need not be same. So read the two numbers having the same number of digit and then multiply the corresponding product, then multiply their corresponding product and finally sum them up. So what is the meaning of it? Take the first digit from the first number, that is 3. Take the first digit from the second number, that is 5. Multiply them, 5 into 3 or 3 into 5. So you got the first number. Take the second number 3. Take the second number from the other set, that is 2. So 2 into 3, you have a second number, and then take the third digit, multiply it with the third digit, that is 7 into 9, add them, so add all of them to get the final sum. So how do we solve them? Let us first do it manually and then we will write the program. Now I am going to take the same number, so I call the first number as x, which is 327. The second number I am going to take it as 539. I call it as y. And we know very well that in order to split this number, we can take the last number out. So we can always take the last number out from the given or last digit out from the given number. How do we take the last digit out? So we know that take this x, go for the remainder operator, and that is the mod operator, divided by 10. So what is the remainder? If you take this number 327, divide it by 10, okay, so what is that you are going to get? You are going to get, remember, the 10, that is 320 plus 7. You know very well, 10 will divide 320. Exactly, it will divide 320. But 10 cannot divide the 7. So what is the remainder? So this is called as the remainder or mod or modulus operator. So the remainder is 327 divided by 10. The remainder will be 7. This is for the first number. Let's go and take the second number, 539. Let us divide this 539 and let's divide by 10. So what is that we are going to get? So 539 can be written as, so this is equal to 530 plus 9. So we know very well 10 will exactly divide without any remainder. 10 can divide 530. What is remaining? Remainder is 9. So if you apply the mod operator on this y, then the remainder will be 9. So multiply these remainder, 7 and 9. So if you multiply 7 and 9, you are going to get 63. So this is the one answer. Now what is that we are supposed to do? We are done with this last digit. Get rid of this digit. How to get rid of this digit? Again, take the x itself, that is 327, divide it by whole thing, divided by 10. What is the answer you are going to get? The answer that you are going to get is 32.7. What is the integer part of it? So this 0.7 is the fraction part. Integer part is 39. So in other words, perform the 32. If you perform the integer division, you are going to get 32 out of it. So 7 can be discarded. That is what we are going to do it. So you take this number 327, which is the integer, divided by one more integer. What you get is 32.7 you are going to get it. So if you take the integer part, so this you are going to get here as in this case you are going to get the number as a 32.7. so discard 32, discard this 7, what you get is 32. In the same way, 539 divide by 10, so what you get 539 divide it by 10. What is the answer you are going to get? The answer that you are going to get is 53.9. Discard the fraction, take only the integer. So this is called as an integer division. So you get this. So from the given number, you have from this 327 and 539, you have successfully eliminated the last. Now you are left with 32 and 53. Perform the same operation. What is that same operation? Take the x first, that is x is 32 now. Divide it by 10. However, the division that you are going to use is the remainder, that is the modulo division. So when you divide it, what is the answer you get? 32 can be written as 30 plus 2. And you know very well 10 can divide 30, but 10 cannot divide 2. So what is the remainder? Remainder is 2. So you get 32 mod 10, the remainder will be 2. Got 1. In the same way, take 53. So take 53. Divide it by 10. However, this division is not the integer division. This division is the modulo division, that is the remainder of division. So 53 can be written as a 50 plus 3. And we know very well that 10 can perfectly divide 50, but 10 cannot divide the 3, so remainder will be 3. So you got 2 and 3. So this is I'm taking at xr as the remainder of x, yr is the remainder of y. So multiply them together. So 3 into 2 you are going to get as 6. So from this 32 and 53, you have successfully multiplied these two numbers. Now reduce this 32 so that only 3 is left, and reduce this 53 so that 5 is left over. How do we go about it? Take this 32, divide it by 10. However, this time the division is integer division. So integer division, this is the integer division. You are performing the integer division. What is the answer that you are going to get? Answer is 3.2. Discard the fraction part, take only the integer part. In the same way, take the next number, and that is the 53. I'm sorry, not this one. Okay, 3. Sorry, this is this should have been this 3. Okay, so take this 53 and divide it by 10. Okay, this time let me divide it by 10. Okay, this time you are performing the integer division. Okay, and what is that you are going to get? The answer that you are going to get is 5.3. Okay, discard the fraction part, take only the integer part. So you got, okay, 5 and 3. In other words, we have successfully eliminated the 2 digit from the 32 and 53. We have eliminated this digits, so we are left with the last 2 digits over here. So let us go and multiply them together. So how do we multiply them again? But we will follow the same routine. So what is that we are going to do is we are going to perform the modulo division. 3 mod 10, remember 10 cannot divide 3, so the remainder will be 3. Again, y is 5 now, so y is 5 now. 5 mod 10, 10 cannot divide it, remainder will be 5 here. Multiply them together, this x remainder and y remainder, multiply them together, you get 5 into 3 into 5 is 15. Now what is that we are going to get? Take this part, take the remaining, you have it here, so take this part, that is the product part of the previous digit. Also take the product part of the first one that we have taken over here and multiply them together. So take the product part of the remainder, first digit remainder, take the product part of the second digit remainder and take the product of the third digit remainder, multiply it. So this is 15, add them together. If you add them together, if you add all of them together, the answer that you are going to get is 63, which is this one. So 63 plus 6 plus 15, so if you add them together you get 84. Now let's go for the next scenario, one other scenario. Now if you look at the numbers over here, I have taken the first number as 327 itself, but the second number is 5. Now you notice that they are not compatible. Why they are not compatible? You notice that there is the first digit is there, but there is no second digit, there is no third digit. So this cannot be used for our program. So we have to say that they are not compatible. How do we go about doing it? We cannot, when we look at it, it is very easy. In the program, how do we go about it? But we assume that both the numbers are compatible. We start with the first number, 327. Mod 10, that is the remainder, is 32 point, so 320 plus 7, so 7 is the remainder. Similarly take 5, not 539, similarly take 5 divided by 10, so the remainder will be 5 itself. 10 cannot divide 5, so this 5. So you have 7 into 5, this is 35. Now because, now what is the next step? Next step is you have multiplied the first digit, this you have eliminated, this you have eliminated. So take the remaining two part. So the 327 out of this 327 divided by, go for integer division. So 327 by 10, what is the answer you are going to get? 32.7. You have already seen this. Discard the fraction part and take up only the remaining part. Again same thing, take 5 divided by 10, integer division. What is 5 by 10? Is 0.5. Now discard the fraction part. What is the remaining is 0. Now you notice that one of them became 0, but the other one is non-zero. So first number is 0, one number is 0, but the other number is not 0. This happens because both the numbers are not the same, they are non-compatible. The first number becomes 0, the second number becomes 0 faster, but the first number is still having some digit. In the previous case, both the numbers, so if you take the compatible one, that is 327, 3 digits over here, three digits over here, both of them will become 0 simultaneously. So x will also become 0 simultaneously, y will also become 0 simultaneously. So if the two numbers, if the number of digits in the given, or the count of digits in the given number are same for both of them, then they become 0 at the same time. But if count of digits of first number or second number is different from the second, or if the count of second is different from the first, in other words they are non-compatible, then one of them will become 0 faster, but other will still be non-zero. So if both of them are not non-zero, then means they are non-compatible. So this is what we are supposed to note that. So if when you are dividing this number, we are reducing it. So what we are doing is, every step what we do here is, for every step we reduce one digit at a time. So first we remove the last one, then last but one, and finally the first digit itself. When we do it, if the numbers are compatible, both of them will become 0 simultaneously. But if one of them have become 0, but other one has not become 0, that means they are not compatible. For example, if you take the number 45, and if you have other number as 468, okay, in that case what will happen? So if first, let me write it properly. So I have this 45 here, and let me 45 here, and let me write it slightly here, and let me take 657 as one number. So what we do is we eliminate the first last digit, we eliminate the last but one digit, but what you notice is one of them have become 0, other one is non-zero, so you cannot eliminate them, so you can't cut them because one of them is already 0. Okay, so it is, if you get confused, so it is nothing but 045, and the other number is 657. So 0 has no value, but 0 is still there, even though I wrote 45 here, it is 045. So you eliminate this, but what you notice is one of them is 0, but the other one is non-zero, so then they are non-compatible. Okay, so if the digits are non-compatible, then you cannot multiply them together, and we have to give the error message saying that they are not proper. So with this logic, let's go and let's solve it in the Netbeans. So I'm going to go to the Netbeans, and I'm going to start a new project, and I'm going to take the Java as my project, and I'm going to click next, and then I'm going to give a name to this project. You can give anything. Okay, sum, I can take sum of products, you can take anything. Okay, you can take anything, you can take it, sum of products, I'll just take it. What we need is we need two numbers, so that's what we need. I'll go to the static void main. We need two numbers over here, both of them are integer numbers. So according to the problem here, they are saying that okay, program will read two numbers having the same number of digits. Assume that they are integers here, because if it is floating point, you will have a lot of other issues also. So let me take the first number as x, second number as y, and you know very well I'm going to take the remainder. So I'll take it as xr is the remainder of x, yr is the remainder of y, and we are supposed to get the product. So I'll take the product, and I initialize the product equal to 0. So this is the initial value, and we need an input. So in order to get the input, you have the class called as a scanner. So I'm going to use SCANN and control space, and I will go to java.utility, press enter, and what the Netbeans will do is it will add an import statement, java.utility.scanner. So that's really required. I'll call it as ESC is equal to new. Again I press control space, and I select the first one, and I need the input output stream. I'll call it as system dot in. So I got it is like your scanf statement. I got that scanf statement. Let me write s out, and I'm going to say enter two numbers. Okay, so let's take two numbers, and if you want I will even remove this ln, let it come in the straight line. Okay, or else it's up to you. Okay, let's take I'll take x is equal to, and you know, sc dot next int. I'm reading the integer because x is an integer. You notice that x is an integer, so I have to read it as a int. Similarly, I am supposed to read y, so I am going to use Control C and Control V. You know very well, copy paste is something that you can always use it. So I read the two numbers over here, and what is that we are supposed to do it. So what is that we are supposed to do it? We know very well. Keep on reading this number, go on doing it until you see that both the numbers have become 0. So as long as both of numbers are non-zero, we are supposed to keep on cutting one digit at a time. So from here, cut one digit. From here, cut the other digit. Keep on doing it until both of them become 0. So that is what we are supposed to do it. So I'm, you know very well, in order to keep on doing something, we say that we have to use the loop. So let us use the loop. I'm going to use the while loop. So while, what is it? X is greater than 0, and remember both of them must be greater than 0. Y is greater than 0. So when both of them are greater than 0, we are supposed to do something. What is that we are supposed to do something? First of all, let's get the remainder of x. How do you get the remainder of x? X mod 10. You get the remainder of x. Similarly, you get the remainder of y. How do you get the remainder of y? yr is equal to y mod 10. You get the remainder of this. Get the product of this and then make the sum. So p is equal to old value of p. Initially old value of p is 0. So if you add something to 0, the answer is 0. But what is that we are supposed to do is we are supposed to multiply the remainder of xr into the remainder of yr. This is what we have done. If you look at here, once we get the remainder, let's look at here. Once we get the remainder xr, once we get the remainder, and yr, once we get the remainder of yr, we multiply them together. So p is equal to the product of these two. So you got it. What's the next thing? So you have consumed the first digit. Get rid of this last digit. So how do we do it? Just go for integer division. So x is equal to x by 10. Similarly, y is equal to y by 10. So you just get rid of the last digit. So when you get rid of the last digit, you get 32 for x and 53 for y. So this is what you are going to get it, and that is what I am going to do here. So how do we do that thing? So I am going to say new value of x is equal to old value of x. Let me zoom in for you. New value of x is equal to old value of x by 10. Similarly, new value of y is equal to old value of y divided by 10. This is going to perform the integer division. I think I pressed the enter sign too many times. So this is the end of this while loop. So let me keep that while loop properly. If you notice that while loop has ended here. So this will keep on doing it until both x and y becomes 0. So there are two conditions. X and y can become 0 simultaneously, like in the first case, or if the digits are not same, one of them may become 0 earlier. So when we come out of this while loop, we need to check whether both of them are 0. So if x is not 0, so in this case, if you look at here, if you look at the last one that I have shown here, so if you notice that both the numbers are not, this has 3 digits, but this has 1 digit. In this case, what happens is y becomes 0 faster, but the x is not 0. So in this case, the numbers are not compatible because one of them has achieved 0, the other has not achieved 0. So in other words, when you cut the number, 5 and 7 are gone, but 3 and 2, there are no numbers available. So there is no numbers are available for the remaining 2 digits, so you can't multiply them. So this is what we do it. So one of them has become 0, but the other has not become 0. So this is when x is larger and y is smaller. Suppose if y is like this, In this case, what will happen is you eliminate this digit, you eliminate this digit, and you eliminate this digit. So x will become 0, but y is non-zero. Still 2 digits will be available. So one among them will be true. So if either x is not equal to 0, or if y is not equal to 0, that means that these are non-compatible one. So in that case, I will not show the result. I am going to use s out and say that numbers are non-compatible. Okay. Else, if both of them are 0, x is 0 and y is 0, that is in this case, simultaneously both of them have become 0. So simultaneously, if you look at this first case, wherein both of them have the same number of digits, then simultaneously both will become 0. Okay. In that case, I can show the output, and I'm going to just zoom in for you. Just a minute. Just zoom in for you, and I'm going to say S out and press the tab and say sum of products is, and I'm going to add the P. What is this P that I have done? P is the one that I'm calculating every now and then. Okay. So this is it. Let's give it a try. I'm going to save it and just I'm going to run it. And you got to enter two numbers. So let me add the two numbers, the first two numbers, and what is that? 327 and 539. So I'm going to use the same number, 329 and 527, 329 and 537. Okay, I think I should have typed it. One, I pressed enter. Okay, when I talk and when I do it, sometimes I lose concentration. I will run it again. 329 and 537. Let me rerun it. There is nothing wrong in it. I just want to show the thing over here. So 327 and 539. Press enter and you get the number as 84. So this is what you get, 84 as your result. And if you compare it with the result that is obtained, you get it as 84. Now let me rerun it again one more time, and this time I'm going to give the non-compatible numbers. So I'm going to say 327, and I'm going to use the next number as 5. You notice that they are non-compatible. That's all in this video. Let me stop this video.